Now that we have defined our vocabulary for observational studies and experiments, we can go through some examples of identifying the experimental units, the factors, and the levels of each factor for several different examples. So this first example here says, in this hypothetical experiment, the researcher is studying the possible effects of vitamin C and vitamin E on canine health. So we have vitamin C, vitamin E, the 6 different possible treatments. So they want to know the experimental unit. And your experimental unit is what is being tested on. And in this situation, dogs are being tested on. So canine health. So I'm just going to put canines. Identify all your factors. So here we have 2 factors. We have vitamin C that plays a factor and or vitamin E. So vitamin C and vitamin E. And then the levels of each factor, vitamin C has 3 different levels. Vitamin E has 2 different levels. So all your levels would be 0 milligrams vitamin C, 250 milligrams vitamin C, or 500 milligrams vitamin C. Then you have 0 milligrams vitamin E and 400 milligrams vitamin E. So those are the 6 different treatment options, really, is the combination of those. But your levels would be the 0 milligrams versus 250 versus 500, or 0 versus 400 for vitamin E. Example number 3 says, over a 4-month period among 30 people with bipolar disorder, patients who were given a high dose, 10 grams a day, of omega-3 fats from fish oil improved more than those given a placebo. So my experimental units are going to be the 30 people with bipolar disorder. But remember, when we're talking about humans, we're really talking about subjects. Or who is the subject? And we have 30 people with bipolar disorder. My factors are going to be a high dose of omega-3 fats or a placebo. And the levels of each factor, so we had 10 milligrams of omega-3s. And the placebo is just a placebo. So you only had 1 level for your factor of omega-3s. The placebo did not have any levels. It would just be a placebo. All right, example number 4 says a study published in the New England Journal of Medicine in March 11th, 2010 compared 2 medicines to treat head lice, an oral medication called ivermectin and a topical lotion containing melathion. Researchers studied 812 people in 376 households in 7 different areas around the world. Of the 185 randomly assigned to ivermectin, 171 were free from head lice after 2 weeks, compared to only 151 of the 191 households randomly assigned to melathion. So my experimental units are going to be the subjects, because we're talking about humans, and we are talking about 812 people with, we are talking about 376 households. And the reason why we're talking about the 376 households is because the households are what were randomly assigned. So your experimental units are going to be what was randomly assigned. So here, they did not say, okay, you are getting the lotion, you are getting the oral medicine. You are getting lotion, you are getting oral medicine. They said, okay, your household is getting the topical lotion. Your household is getting the oral medicine. So because the households were randomly assigned, your experimental units are going to be the 376 households. Identify the explanatory and the response variable. So the explanatory variable would be the medication, and the response variable would be the head lice after 2 weeks. All right, identify the treatments in this experiment. So the treatments were the topical lotion and the oral medication. So the treatments, treatment 1 was topical lotion, which is called Malathion, and treatment 2 was the oral medication called ivermectin. So those are the 2 treatments, and the households were randomly assigned to one of those treatments. Okay. Last but not least, we need to compare observational studies to experiments. So overall, we have 2 main ideas right now. So main idea number 1 is that observational studies, so they study the effect of an explanatory variable on a response variable. And observational studies often fail because of confounding between the explanatory variable and one or more other variables. So observational studies often fail in creating cause and effect statements because of confounding variables. That's why in AP Statistics we say that observational studies can never result in cause and effect. Experiments don't just observe individuals or ask them questions. They impose some kind of treatments to measure response. So for each one of these examples, we're going to go through 3 examples. We need to determine explanatory and response, and then experiment or observational study. So example number 5 says, a survey of over 7,000 randomly selected employees in 15 nations recently showed that employees who work in a digital workplace tended to be happier than those who don't work in a digital workplace. So observational study or experiment. And whenever you have survey, that means they're just asking questions. They're not putting people somewhere, anything like that. So this is going to be observational because they did not manipulate or change anything about the situation. They just asked questions. So observational. Explanatory variable is going to be happiness. How happy were the employees? Oh, no. That's going to be your response variable. Your explanatory variable was the digital workplace. So the digital workplace explained happiness. I got ahead of myself there. So your response variable is always what they're measuring. Explanatory variable is the reason behind your response variable. It explains it. All right, example number 6 says that according to a study published in the journal Psychological Medicine, ayahuasca, a drink made of Amazonian plants, can help people with depression. The study involved 29 participants who all had depression. Doctors gave each of the participants either ayahuasca or a placebo beverage that looked and tasted similar. Those who drank ayahuasca showed significantly lower levels of depression compared to those who drank the placebo beverage. So is this an observational study or an experiment? You should be thinking right now, experiment, because the doctors manipulated or gave them some type of treatment. So this is an experiment. The explanatory variable would be the ayahuasca. Oh man, ayahuasca. And the response variable would be level of depression. All right, last but not least, maybe try this one on your own. If you don't want to, let's do it together. So example number 7 says, employees at a video streaming website suspect that users on desktop computers spend more time on their website than users on mobile devices. They plan on taking a large random sample of users to see if their suspicions are correct. All right, observational study or experiment. So you should be thinking right now, are the researchers manipulating or giving anything to the subjects to change the outcome? And the answer is no. So this would be an observational study. They are just going to be asking questions. Explanatory variable is going to be the desktop computer or mobile device. And the response variable is the amount of time on a website. So remember that you still have an explanatory variable and a response variable for both observational studies and experiments. It's just a different type of study. And for observational studies, you cannot say one causes the other, but for experiments with enough significance, which we'll talk about here soon, you can determine cause and effect. So that is the conclusion of Unit 3, Packet 2. Make sure you have a full understanding of observational studies versus experiments when you come into class, and I will see you soon.